Live from Harbor Station, it's the Vector Spaceman Show. Now here's your host, Vector Spaceman.
Hey-o, 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 Space Cadets. It's your old pal, Vector Spaceman. How's everybody doing tonight? We're back at it again, coming to you live once more, straight from Harbor Station and broadcasting on all frequencies to our beautiful planet Earth. Now, let's zoom on out here. Zoop, 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 zoop. Whether you're watching us live or catching us after the show, you best believe that we're glad to have you on board. Thanks for helping us all make outer space the place to be on tonight, Tuesday, March 5th, 2024. You guys, welcome back to the program, and if it's your first time tuning in tonight, then hey, welcome aboard. I'm Vector Spaceman, your host of the Vector Spaceman Show, a sci-fi animator, games and music and other fun stuff VTuber, bringing you a regular dose of maxin' and chillaxin'. But we're back on the Godot design kick tonight. I'm jumbling up all my words. As we return to our little Twitch-integrated minigame concept. That'll be fun. Ooh. We're going to try to add a new power-up tonight and maybe improve some of our existing UI as well. Now, if you missed the last show, we checked out the new language-learning photography game Shashingo, brushing up on our Japanese and touring through a little fictitious Japanese neighborhood. Had a lot of fun, learned some new words, and we got to reflect on some experiences of our own times back living in Japan. Very cool game. Mad props, of course, to the developers, and it's a title that we may return to in the future if the game decides to give us any new updates or areas to explore. But for now, you can check the replay over on our YouTube page, and remember that if you want to stay updated with our broadcasts so that you never ever miss a show, then be sure to follow Vector Spaceman on Twitter, YouTube, and of course, right here on Twitch. What the? Oh, wrong button. There we go, there we go. We are off to an amazing start tonight, you guys. Happy March, Space Cadets. It has arrived like a champion. It's nice and sunny and warm down below Harbor Station, though that may not last long, for all we know. We'll be into typical spring weather sooner or later, but in the meantime, I get to go biking and walking about and having a good time, and it's been a good few days. That's for sure. That's for sure. Hello, Buffy. Nice to see you. Are you ready to take control again tonight? We need expert pilot Space Buffoon at the helm as we continue our work on the minigame. Evenings, of course. These are for streaming, so that's what we're here to do. We're headed back to our Godot project tonight. We're going to try to implement some more spawnable items, some power-ups, some fun features. Just like last time we did one of these streams, I've done a little bit of work between broadcasts. We did switch gears last week with our Shashingo stream. But I'll be sure to explain everything that's new so that we're all up to date, so we all know what's going on under the hood. We all understand. It's an educational program, of course, you guys, of course. So this will be another laid-back, casual stream tonight. We'll be working and problem-solving together, maybe even learning a thing or two along the way. Say hello in the chat. You know we always appreciate it. Or just kick back and let Spaceman talk your ear off for the next hour or so. Whatever you like, we're glad you're here. Now, let's get our typing hands on, you guys. Here we go. Arms, bam, put out the tablet, and let's head on over to the big screen, shall we? Here we go. Zoop, 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 zoop. Wow, we're here. And we've got a little extra buddy with us tonight. This little rubber duck asset that was made by a friend of the show, Nep the Floridian Man. And the reason that this came about was I was telling stories last time that we were doing one of these about how there's like a teachable practice about having some sort of totem, typically represented as like a rubber duck or something like that, some sort of animistic, spirit animal of coding to keep by you that you can explain your process to, so that you understand it. Because in order to code well, you got to be able to know what you're doing. You got to be able to explain it well. So we got our little duck here next to us. That was nice of Nep to throw together. And who knows, we might have to make use of his duck-like charm to explain some of the things that we're working on tonight. Now let's talk about some of the changes that have been made since the last time we did one of these. So we've still got, oh, actually, you know what? I should activate our redeems, even though presently they're not going to do anything. So they're going to show up in the Twitch redeems move up, move down, launch a missile, all the classics. They're not connected at the moment, so don't bother redeeming them, but we are going to need those for later, so that's why we're keeping them there. Alright, so first things first, let's pull up our code base here. Bam, here we are. And I'll try to zoom in to explain some of the things that we've got going on. So, we've got a new enum variable for the Spacevan, which we're calling van state. And this includes 3 different states: alive, damaged, dead. And this keeps track of what state the van is in. So when it's alive, it's just cruising around. When it's damaged, it's going to do a little jitter now, like when it gets hit by an asteroid. When it's dead, that's when we're going to take it out of commission. That's one that we haven't implemented yet, but we might get around to that tonight. Let's see. We've made some updates to the way that the Spacevan moves. We'll get to see that in a moment. So you might remember from the last stream, it moved pretty stiff. We implemented a sort of false mouse tracking sort of feature that sort of projects out in front of the Spacevan. And it makes a nice sort of interpolated motion, like a nice smooth sort of swinging motion when it moves up and down between lanes now, which is nice. What else have we got here? So we now have a take damage function. And what this does is this tells our Spacevan to sort of jitter around a little bit when it takes damage, which is good. So when it gets hit by an asteroid or anything that we can designate, it'll do a little jitter here. And the way that we've implemented this is in our game manager class. We've added a new class called a timed routine. So we can tell the game manager, which up until this point has been doing a background time tick every frame or every physics frame. So we're gonna tie our deferred calls to that. So we can say, all right, every time that we tick, we subtract from a number that we pass through this timed routine class. The timed routine class takes a timer, so what we're counting down from. It takes a method, which is what method is going to be called once that timer reaches 0. Parameters, and then a Boolean value is continuous. So if it is continuous, it's going to be doing something the whole time that happens. If it's not continuous, it's only going to do that. It's only going to call that method at the very end. That's useful for us because it means we can jitter every frame. It also means that we could do something like send a message when some sort of countdown is finished. Something only gets called when that countdown reaches 0. So that's useful for us. And we can demonstrate what that looks like by pulling up the game here. So first thing we're going to do, we are going to reactivate our Twitch connection. Here we go. And we're going to go into Godot. Oh, and the last thing that we should show off, and this is actually a little feature that we sort of brainstormed when Buffy was here last time, actually, if Buffy's still in the chat. So our high score now actually has a pilot value along with it. That name will change. But if we go into our high score value, let's see, where is our high score data? Data, high score JSON. So our high score now is now stored in a JSON file instead of just a text file like it used to be before, which now contains the high score, the present high score, as well as the pilot that got us to that position. And the way that we determine who that pilot is just the last person who did a redeem in chat. Or specifically who did an up or down redeem, I believe is what it's written as right now. But we can always change that as well. So we are going to, thank you so much, Hikari. I do need a drink. Like I said, I've been out, I've been active, I've been getting exercise. It's been great, but it's been tiring. We're a little exhausted. You can sort of tell from the way we've been jumbling our words tonight, but we're gonna do our best. All right, so as you can see here, our present high score is 57. That was just from me messing about with it. We're gonna change that to 0. So we're just gonna reset this. Our pilot is presently nobody. So here's what's gonna happen. We're gonna run the game, and the first person to input an up or down command. Also, hello Neff, how are you doing tonight? Welcome to the stream, welcome to the show. We're doing the mini game tonight, it's fun. Maybe you can take control and get yourself a high score, Neff. Check this out. So we've got redeems on the Twitch chat. Move up, move down, fire missile. They're all very cheap right now because we're just doing testing. But here's what we got. We got our little space van flying through space. Okay, we're not running the game, so that's why you're not seeing anything happen. I'm sorry about that, Neff. You've been robbed of a single cadet credit. My apologies. Here's what we'll do. We'll run the game. You'll get to see it in action. I want a refund. Do you want a refund on your coin? I'll do what I can. You know what? I'll manually fire a missile for you. Boom! There you go. Alright, so as you can see, our high score is ticking up, but because we haven't gotten any input yet, we don't have a recorded high score pilot. So as soon as somebody redeems an up or down command and gets a new high score, there we go. And as you can see, the Spacevan now jitters about when it gets hit. So that's fun. So Neff is presently our high score, our high scorer. Oh, gotta be a little faster than that. The asteroids are still spawning a little close together, so I'm thinking that we might change some of the spawn patterns, some of the disallowed spawn patterns. And yeah, of course, you can also fire missiles to get rid of those asteroids. You can see once one of those collides with something. You're seeing a lot of missiles go today. Okay. Oh, missile, quick, missile. Oh, almost. Just non-stop missiles, that's all we've got. Can't see anything in the chat, but missile redeems. Neff's just cheesing her way to a new high score. But there, as you can see, when missiles collide with asteroids, they blow up. It is the Nep duck. Yes, we're trying our best to explain our concepts here with the Nep duck. How are you doing, Nep? Nice to see you. Buffy's taking over the high score. Check that out, you guys. We got a new high score. Neff's really handling the missiles. Buffy's handling the motion. This is good stuff. This is good stuff. This is what we call teamwork. Oh, and Hikari steals the new high score. Oh my goodness gracious! And Nep is stealing our heart and our appreciation. With subs, with gifted subs. Thank you so much, Nep. Everybody, say thank you to Nep if you happen to be a recipient of those lovely, lovely subs. What a champion. What a friend of the show. Oh boy, we are just colliding nonstop into these asteroids. So one of the things we want to implement is like a game over when we collide into an asteroid without any coins. Because right now we're doing like a Sonic thing, where if we've got coins, they sort of explode out and we do a little jitter. But if we were to collide with 0 coins, that's when we're gonna make use of the dead state on the Spacevan. Right now we've just got alive and damaged, but we want to implement the dead state as well. I just wanted to say hey and leave. Thanks, Vector. Well, thank you so much, Nep. Hope you have a wonderful evening. Thanks for contributing. You'll still be with us in spirit, in duck form, and that's what's important. I do love those big explosions. Those big coin explosions, those are so much fun. Buffy's launching missiles. And, actually, I think we have, here, I want to show off, so stop your redeems for a sec, because I want to show off something. We're going to close this down. Okay. We're going to go back into our JSON here that records our high score. Hey, yo, gifted Spaceman. How's Meg? You got one of those too? Make sure to thank Nep. Yep, there you go. Alright, so as you can see, our high score is 26 at the moment. That pilot is Space Buffoon. The way that we record that, if you guys recall, and we can see it down here in our output dialog area, anytime that somebody redeems a, how you say, Twitch redeem, as it were, we get all sorts of information from that. So we get the broadcaster ID, that's me. We get the ID of the person who redeemed it. We get the ID of the reward that was redeemed. So that's where we can get the username value here. Space Buffoon. That's great. So that's what gets passed into our high score JSON. That's very good. Do you get your IP? No, we don't get your IP. What else do we get? We just get your ID. Now, just public stuff. If you didn't know your user ID, Neff, maybe we can find it for you here. I think you can actually just find this stuff by looking it up through Twitch. But no, it's all public stuff. So nothing to worry about. No compromised information or anything like that. Also, how are you doing tonight, Meg? We're just working on the space van presently. All right, so here's what I wanted to do. We're going to reset the high score to 0. We are going to remove, or actually, I'll show you kind of how this works. We're going to completely delete everything that's in the high score JSON, the JSON. Then we're going to close that, and then so nobody can interfere with our demonstration here, we're going to not connect to Twitch, and then we're going to run it. And if we just let this run, high scores will still tick up, but because we don't have anybody on the redeem, we don't get that pilot coming through. And one thing that I want to implement is that, because right now I think our pilot value is always tied to the last person who redeemed an up or a down, which conceivably could mean that if we had a really low high score or something, and then, you know, we lost it all because we hit asteroids, let me hit an asteroid or something, and then we lose them all, but then we just get like a whole long string of coins or something like that, and it ticks over again, whoever was the last person who redeemed would still get the high score. I think we want to change that so that it becomes a null value or something like that. We also need to space out these asteroids. But one thing, if you were here from the last time that we did one of these, you might notice, is that all of our illegal patterns are now working. So we're not getting walls of asteroids. We're not getting night patterns where it's like 1 and then 2 down. We're not getting other like crosses and X shapes and stuff like that. So we've got a very good system for that now. But we could build upon that and sort of stretch it out so that, like right now, we have it set so that an asteroid can't spawn directly after an asteroid. But we could also make it so that asteroids can't spawn like within 2 of each other or something like that. We could really try to space it out so that people making these redeems have a lot more space to move the van around, you know? Because we are still getting ones where it's like one here and then there's another one like right there, and you sort of have to be real quick to navigate through it all. Or another thing we could do, we could try to tie that to the present score. So we can make it harder to navigate as the score goes up, so that it's not just sort of about luck of the spawn patterns, but it gets more condensed as the score ticks up and up. That's actually not a terrible idea, and that's something that I might implement behind the scene. But probably not on stream tonight. On stream tonight, we are going to try to work on a new power-up, because isn't that fun? Alright, let's close this down. Let's go back to our code. Re-implement Twitch connection. So that's ready to go. Okay, so what we wanted to work on tonight was the magnet. And the magnet is one of our little power-ups that we have here. Ba-ding, the magnet. And the magnet pops out of the space van and it draws coins toward it, so that it well, makes it easier to collect coins without having to move up and dodge stuff and all that. We've also got, what do we got? We got the bubble shield power-up that we want to implement at some point. And what else do we have here? We've got the launcher, which was supposed to sit like on the hood of the space van or something like that, and that would be where the missiles come out of. That was the idea for those. What I think we're gonna try to work on tonight is the magnet. Because the magnet we'll have to interact with the coins like a radius and draw them toward it. That's going to take some coding, so that's what we're going to work on. You know what? I just realized we've had the station background music going this whole time. Not that it isn't a rhythmic bop, as it were, but let's put on something else here. Let's see what we got. YouTube or something. Here we go. Okay. Switch our audio. There we go, a little jazzy. Okay, music for thinking. Music for coding. Alrighty. So, in order to get our magnet to appear, I think it's going to be something that appears via a redeem. Remember that our redeems at the moment are sort of, how you say, super cheap, because we're all just experimenting, what have you. I'm thinking we'll probably attach the magnet to the Spacevan. That makes sense. Then we'll just have it appear and activate when necessary, because we can always make items visible and invisible. So we'll just add it to our Spacevan prefab, as it were. So we'll parent it to our Spacevan. The Spacevan. Should rename this sprite to be to Spacevan body. There we go. So now, test this out. Should be behind. Let me select the things I want. There we go. Are you kidding? Okay, there we go. That should be, yeah, that's behind technically, so that's good. Position it precisely where we want. I think that looks nice. Remember, we can make that visible or invisible. But now, because it is parented to the collision shape, which is itself parented to the Spacevan node, that means that if we run the game right now, we're going to see it move with the Spacevan, and that's great. And now all we need to do is implement a script for the magnet itself, which will draw coins toward its position. That's actually pretty straightforward. But let's get to work on that, shall we? So like all of our other nodes, or spawnable nodes, this isn't going to be classed as a spawnable, but it is going to have a area 2D that we're going to have to add to it. Edit that area 2D. That area 2D is going to need a collision shape. Collision shape 2D. We're going to create a new circular shape. We're going to make it big, because we want it to draw in coins. So basically, anytime that a coin spawnable passes into this area, it's going to start to move toward the center of the magnet. And you know what? We should center the area 2D like here. That's where we want it to draw toward. And games is fun. Okay, so that's good. Now the only issue is right now coins don't get added to our store unless they collide with the space van itself. That square there is the space van's collision model. So let's actually change that to be like here. That's where we're going to draw our coins. Once they collide with the space van, the alternative to that would be creating a space van, or creating a collision shape for the magnet that gets added to the space van's collision shape when the magnet is activated. I wonder if we can do that. So right now we're just going to do it like this for testing purposes. And I think we'll make it just a little bit bigger. You know what, we can't make it too big because then you can just like draw everything in from the center of the map. Something like this should be okay. We'll see how it works, and we'll make alterations if necessary. Okay, let's save that. Now we need to create a script for the... Let's look at our existing code base. We can decide whether we need to create a script for the coins or a script for the magnet itself. Let's find out. So let's look at our spawnables. Spawnables, which include the coins, have a vector2 direction, and it is currently public, so that's the easiest thing to modify. We can just change the direction that it's heading in, and have it travel toward the magnet. Okay, so because we can access that publicly, we will just create a new script for the magnet itself. Oh, ads are starting. Okay, let's create a new script. We'll call this magnet. Save this to our scenes, our scripts. There we go. Alright, now let's make some connections here. Presently, the only connections we have are in our spawnables. Let's take a look at our coin packages, for example. Yeah, so these are area 2Ds, which, and you know what? Spaceman, when you think about it, yeah, we shouldn't have attached that to the magnet sprite. No, we should have attached that to the area itself. That makes more sense. Move that script. We're going to rearrange what we've got going on here. So the area 2D, I'm going to be parented to the collision shape. Magnet sprite is going to be parented to the collision 2D, or to the area 2D. My bad. We're going to call that area 2D. We're going to call it magnet area, or magnet radius. That's still fine. We do want this to be behind the space van, so we'll throw it there. There we go. Alright, should be good. And as always, we can toggle it off and on. Fantastic. So let's delete our existing magnet because it's going to be inheriting a sprite 2D, and we need one that inherits area 2D. Okay. Create a script. Call that as we can see, it inherits from it. Alright. And see, wrong. Okay, I think we're on the right track now. Let's look at our node. We've got signals that we need to apply here. Okay. So when a area 2D enters this area 2D, that's what we're paying attention to. We can see similarly what we've written for our, for example, our spawnable, which also inherits from area 2D class. We have a on area entered method, which it's called when that happens, and that is tied to the built-in signal. Normally we would use like a connect method to manually connect our signals and use event handlers, but thankfully Godot lets us cheat a little bit in the inspector, so we'll make use of that. Here's what we're going to do, NepDuck. We are going to, first of all, we are going to need some values for our magnet class. Let's see, we're going to need that on area entered. Which takes an, oh, hold on. Which takes an area. What problem? Not recognizing 2D. Valid class. This gets saved. Oh, you know what it is? I know what it is. It's because we didn't save it in the... Alright, we're gonna do. Close this. I don't want to save that. I actually want to delete that from codebase. There we go. Alright. Attach that script. I'm going to make a new script. We are going to physically put it in the right folder. Leave it in the right folder. Silly. Magnet. Inherits from an area 2D. That's what we want. We create. Now we're cooking. Alright, we need that, area entered method, which takes an area 2D, and then we'll do something. We also want to have a override method. On ready, override. I don't know. See the member type. Oh, I see. Public override. Void. Okay, looks like we're back. Space Cadets, you let us know if we're back. Hate how common this is becoming, these little disconnects that we're getting when we're streaming. It really is a hassle. Alright, as I was saying, we need some override methods. We need a physics process. Here we go. Alright, that's what we're used to seeing. And we're actually probably going to need export some useful information here to the inspector so that we can change stuff like the strength of the I don't know, that kind of looks like we're back. Twice in one night in almost as many minutes. That's rough. It's getting rough out here for a streamer. I'm telling you. Alright, as I was trying to explain, first thing we're going to do is connect the Godot built-in signal for when Area 2Ds collide with other Area 2Ds. We're going back into Godot here. Go dot. And we want to connect that area entered signal. Oh no. I know, we're up and down, we're the stream is all over the place. But we're back. We're back, Buffy. At least I think we're back. You let me know if we're not back. Because I'm functioning under the assumption that we're back. Are we not back? I could have sworn we were back. Okay, we're back. Very good. Alright, we are going to connect this signal to our it found matching given filters. Well, hold on. It's because we didn't rebuild yet. There we go. Alright, now let's try. Because we didn't save here? No, we saved here. Let's try running it. Now let's try connecting it. Why are you not showing me the compatible methods here? Yes. Unless we can just call an override. Have we been doing it differently? Not realizing it? Let's try that. Let's look at some documents. Let's see. Spawnable. I know we do the same thing here. On Area 2D. Private. Doesn't have to be private. Seems like a strange stipulation. Let's see. Sense. We can look at the methods in the Spacevan script. I want to look at the methods in the magnet script. It's not letting us for some reason. Show me my coin tab. How did we do it? We were able to connect to ourselves from here. How come we can't do that? For our magnet, that doesn't make any sense. It's not showing us any. Attach that. Drag a new script on. Whatever. Alright, fine, I guess. That's just a Godot error then. That's not... We weren't doing anything wrong there, it just didn't want to recognize it. Oh, don't you love programming, though? Don't you love it, Nep? Don't you love it, little Nep duck? Alright, let's get to work here. Alright, we're gonna make that connection. Now, anytime that a Area 2D collides with this Area 2D, something is going to happen. We need to define what that something is in our onAreaEntered. Entered. Can't spell. And for testing purposes, we're just going to say, we're going to print a little message that says, magnets collided with, then we will pass the area dot, I don't know, we're gonna have like an ID. No. Area 2Ds have, what do they have that we can make use of? Do we cast it as a spawnable? I guess that could work, right? How do we do it with the Spacevan? We hit stuff with the Spacevan. Let's see. We don't actually, because we leave that all up to the spawnable. How does spawnable do it then? Ah, we check groups. Okay. So we'll just assign a group, the coin, and then we'll tell that coin to drift closer to it. Area.group. Get groups. That comes back with an array of strings. We'll just grab the first one. Sorry. Get groups. Index 0. Dot. ToString. A little convoluted, but it'll work. Let's see here. That might actually detect the Spacevan as well, now that I think about it. Let's open up the... Well, let's make sure that this is still connected and entered. No, we want it to be on area. Disconnect that. Enter. Go. That's a little clumsy that we can't refactor from inside the IDE. Oh well. Okay. Got an error message here. Cannot instance script associated class found. Okay, that must have been what was giving us problems before. We're still getting that. Case sensitive. We'll see what happens when we try to run this. Okay, but we're not going to run it yet because we have to edit our coin first. Let's pull up our coin prefab. And we want to add coins. So it is a collectible. We want to add another group. I'm going to call it coin. Hey, Zekriox, how are you? We're doing some Godot streaming tonight. Some good old Godot streaming. Trying to make a magnet power-up that's going to work with our coins. So here's what should happen. Right now, any other Area 2D that enters into this radius is going to cause the magnet to identify whatever that is. Either a collectible or a Spacevan, or, hopefully, a coin. We're going to run it here. But I should keep this small so I can read. Look at that. Magnet collided with coin. Magnet collided with obstacle. Magnet collided with obstacle. Somebody's moving the van. Who was that? Oh no, that was just us jittering. because we hit something. Okay. Now we're getting a lot of debug messages here. What are our errors? Let's see. Argument was out of range of valid values. Okay, because we're hitting things that don't have a group. Okay. That's not a huge error. Again, that was just placeholder. Alright, we can stop running that. Go back to our code base here. So instead of printing, hey, we've just hit something, let's actually do something with that something. You know? You know? Alright. First of all, do we have anything that isn't a spawner? We can collide with. We've got the Spacevan, but I don't think that's ever going to get hit. I'm good, love game making, but I suck at coding. Well, you know, that's why you gotta have a handy-dandy little coding totem here. Like we've got our nep duck that we can explain concepts to as we're working, so that we don't confuse ourselves, because that's easy to do too. I think of all the sort of like freeware game engines though that you can work with, stuff like Unity or Unreal Engine, or specifically Godot, which is what we're working with tonight. Godot is probably one of the most approachable. Like, I've really been impressed, even though we do occasionally run into errors and stuff, like silly errors that really shouldn't exist. It's pretty easy to get a grasp on, even if you don't have a whole lot of coding experience, or if you're just bad at it. I recommend anybody who's interested in doing a little coding to give it a whirl. In fact, we might be doing our first little game jam at the end of, at the end of March. Hosted by friends of the show, Game Grotto. Let's go ahead and give a little shout out to the Game Grotto. Meg and Don, fellow virtual streamers, friends of the show, independent game developers. Check them out. But they're hosting a game jam called the Just for Laughs Game Jam. And that's something I'm interested in taking part in. Buffy says, I want to participate in the game jam, but I'm intimidated. Me too. Me too. Which is why I'm thinking it might be better to like try to put together a team. That way we can pool our resources, our skills, or lack thereof. Kind of reminds me of old school Newgrounds games, or new school Newgrounds games. I mean, Newgrounds is still kicking. Now we're talking. Yeah, now we're talking. Put the whole team on it. Okay, here's what I'm going to try to do. When we collide with something, we're going to try to cast it as a spawnable, so we can interface it with it a little better. What that means is, we're going to say spawnable collision, so the thing that we just hit, equals spawnable area. There we go. Okay, it will let us try that. That's good. And then we can say, let's try a different print method here. Or you know what? Spawnables all have IDs. So we can just say if the spawnable ID equals coin, if collision, you know what? That's actually a good check here that it's recommending. But if the collision isn't null, which is to say we have been able to cast it as a spawnable, then we can say if what was it? If collision.id, collision check. If collision.id equal to coin, then we'll just do a little print function so that we can keep track of it in our log. We're gonna say, it's a coin! And that's just gonna let us know that it's working. Alright, so let's try running this. Let's try running this bad boy. pay attention to our output down here. So we're gonna hit A. It's a coin, it's a coin, it's a coin. We're hitting a lot of coins because remember that radius is pretty big. Alright, but that's good. We're detecting coins, and that means that we can alter the direction of those coins. Let's close that down. Go back to the code. Okay, so instead of printing that it's a coin, we want to actually modify the direction that the collision object is moving in. So we're going to say actually, you know what? I just thought of something. This only gets triggered when the coin enters into this radius, which means it will flow toward the present position of the magnet. But if we were to like move down a lane or something, let's say this is the one we're tracking. It'll start to move toward the magnet, but if we move down, it'll only keep moving toward where the magnet was. Whereas I would like it to sort of always curve toward the magnet as it moves, which means updating its direction every frame. So we need, let's see if there are any other built-in signals that we could use here to make our lives easier. Alright, magnet. Show me your secrets. I mean, one thing we could do is just, like, keep a list of... Yeah, that'll work, I guess. This might be bad practice, because this might open ourselves up to memory leaks, but here's what I'm thinking. When we enter the area, we're going to add that spawnable to a list of spawnables currently in the magnet's radius of influence, if you will. And we're going to create a new area visited function, which will remove that spawnable from our list of spawnables currently in the magnet's radius of influence. So basically, and then we can call every physics frame, we can update all of our listed coins, because we're only tracking coins really, to flow toward the center of the magnet, wherever that might be. So we can update that every frame. It's just kind of a roundabout way of doing it. So let's update this here. We're going on area exited. Okay. So we're going to do the same thing, basically copy this code here, down to here. Now we need to replace this with adding the item to a list. So that means that magnets are going to need to have a private list of spawnables. We're going to call that I guess we'll just call it influences. So when we ready up, we're going to say this.influences equals a new list of spawnables, so that will reset it. And now, if it spawnable is to enter into our area of influence, then this dot influences add collision. And we're going to do the opposite here. This dot influences dot remove collision. Here we go. Fancy, fantastic. Oh, except is that going to is that going to work, I wonder? Because the collision, we're casting this area, I guess they're unique. They're unique in the game's logic, so I was worried that when we remove, since these are all going to be coins, if we remove one of them, is it going to try to remove all of them? But I don't think that's how it's going to work. Thankfully, I don't think we're going to have that problem. If we do have that problem, then I'll feel smart because I called it ahead of time. Alright, now we can test this. Every physics frame we can print the number of items that are in our influences list. So if this is working the way we expect it to, then that number will go up, and it will come down when those coins exit our area of influence. And if they don't come down, or if they go up and then all disappear at once, then we know we've got a problem. Let's run this. So 0, 0, it should go up to... Okay. We're going up to 1 and then down to 0. Oh, 3, 1, 0. Getting all those dead coins. 1, 2, 1. We should go 1, 2, 1, go 1. Should get up to like 2 or 3. Okay. I think we're okay. I think it is working. I think it is working the way that we want to. Alright. Whew, I was worried there for a second. If we go down here, we'll see it working way more. It should go up to like 3 or 4. Alright. Now. And also they're disappearing because they're hitting the ship as well. Spacevan. I wasn't considering that. The stakes just got so much higher. So much higher, though. Alright. But we were lucky. It worked out the way that we expected it to. And that's always a pleasure. So instead of printing the count, what we're actually going to do is change the direction of each of those objects. So in order to do that, here's what we're going to do. We are going to take a short break so that I can run and get rid of some of this hydrate redeem that was given to me at the start of the show. So we'll break for like 3 minutes. Here's what I'm going to do. I'm going to let the game run in the meantime, and you guys can control the ship and see what happens. See if you can rank up a new high score. Let's see here. All right, we're going to pull this up. Run it. Blow it up, and I'll be back in a second. And we're back. Oh, and that's annoying. It looks like the redeems weren't working. Hold on. I see Buffy redeeming a lot of stuff. This happens every so often. We run it. Now, the missiles aren't gone. Problem is, we didn't connect to Twitch. Let's see. See, we have here connection error. I need to build in an auto retry, but we can get this running. There we go. Now we're connected. Now we should be able to move up and down. Yeah, that wasn't anything that we messed up on. That was just bad Twitch connection. Whew. All right, we're back. It's good to stay hydrated. Maybe not too hydrated. There goes your missile. Beam, beam. Buffy does love those missiles. Can't get enough of those missiles. You got one. Well done. Oh, you better missile. You better missile. Dah. Alright, that's fun. Belay your redeems. We're gonna shut that down. Oh, one more explosion. One more explosion, maybe? Oh, yeah, nice. Nailed it. Oh, he's going. Buffy, you gotta stop. You clipped another one. Good job. Listen, I'll let you run out as many missiles as you want, but we gotta get back to work here. All right, I think you got them all. I think you got them all, Buffy. You can't. You gotta contain yourself. Alrighty. Let's get back to work here. We have to change the direction of every spawnable in our influence list. So what we do for that is we're just going to, well, we're going to create a dedicated method for that. We're going to call it private void update influence. Influenced spawnables. And we're just going to make a simple little for loop. We're going to say for each. So for each spawnable in influences, thanks to autocomplete. So for every spawnable that's in that list, we're going to say spawnable dot direction, the direction that it's, so its trajectory, its velocity. Well, not technically its velocity, because velocity also needs speed, but its direction of motion, its heading, the way that it's moving. We are going to update that to draw that toward the center of the magnet. I'm thinking, should we also apply like a, might be better to like slightly rotate it. And then we could also apply like a weighted variable, a magnet weight, that we can tweak so that it looks the best that it can. Here's what we're going to do right now. We're just going to do a quick test. We're going to say that its direction is equal to its location, so its position, angled toward, move toward, angle to, turns vector in radians, so angle to point is what we want. That point is going to be this dot position, so the magnet itself. Oh, but hold on, the angle to the point is a... Oh, actually, well, that's a float value, right? Radians. Okay, also float. So we need to rotate it. Is that what we want to do? I think that's what. Or we could just... No, now that I think about it, we could just subtract this position from the spawnables position. Pretty sure that would work. So, this dot position minus the spawnables position. That's a pretty quick hack. Let's see if that works. Alright, so now anything that enters into our... or any coin that enters into our sphere of influence, it should start moving toward the magnet. It's not. Our coins are not. Oh! Doi, Spaceman. Because you didn't actually call that during the physics process. We set up the method to be called. We didn't actually call the method. There we go. Alright. Dumb old Spaceman. Alright, let's try it again. Now we should see them making pretty sharp turns toward the center. Alright, they're sort of like popping out of existence. Why is that? Is this position... is considered... need like a global position, don't we? I bet you they're like showing up somewhere off screen over here. The rotate. Yeah, okay. Rotate by an angle. That angle is going to be the angle to a specific point. So we spawn up position. Angle to point. This dot position. Like this dot global position or anything? I can get a global position, actually. Alright, that's helpful. Alright, let's see if that works for us. Now we should see them curving rather drastically toward the center of the magnet. Oh, they're actually going the opposite direction. Okay. So we have created the exact opposite of a magnet. We need to reverse the polarity here, you guys. Repelling these magnets, or these coins. Oh no is right, Puppy. This is getting to be a problem. Too many drop-offs tonight, but I think we're back. Gonna have to do some editing after the stream. I always hate that because I gotta stitch all the different parts together so we can put this up on the VOD channel. Alright, but as we can see, our coins are wigging out. They're going the exact opposite way that we want them to go. So, how do we fix that? Let's see. We could just put a negative sign in front of the value we had before. See if that works. We just invert the polarity. Now? Oh, no. They're still going for a ride. Get back here. Get back here. Get back here, coins. Look at this. We can, like, trap them. Somewhat. Well. Thought that would be pretty straightforward, but apparently not. Alright, well, this is what the problem solving's all about. Okay, let's see. We change this to just this dot position. Is that going to send them all flying off screen like we saw before? What happens when you get close, coin? Zoop, zoop. Yep, they all do a U-turn. Some of them get caught in like a little orbit. That's fun. But why are they doing that? Why are they? Let's examine. Alright, we're telling them to... You know what? Could we not just do this? We could say, instead of trying to mess with its actual direction, which is defined by the spawner that the spawnables come out of, could we not just say spawnable dot position? Like we could manually edit its position. Equals spawnable dot position dot move toward this position. And this is where we get a delta value, so a weighted value. Let's say we're gonna have to assign. We're gonna export this so we can tweak it in the inspector. We're gonna say private float what is it gonna be? Magnet strength equals, and we'll give it a base value of 0.1. Let's see what that looks like. Be a very gradual draw toward it. So some of those coins might even escape the magnet's range. Which is kind of cool, we kind of like that. And this means that we're also going to have to pass frame delta value through this method. Say this dot magnet strength times delta passed as a float. Okay, let's go into Godot. Reload this, we can see we now have a magnet strength applied to our magnet. Run it, see what happens. We're either going to get a problem where it zips over here again, or might just be too faint to notice the level of attraction. So let's change this to 0.5. This is why we like having fields in the inspector and analyze them. Performance. Oh, I don't know if they're getting any closer to the magnet. Change it to 1, it should be immediate. Oh, wait a minute, no! Now, if we change it to 1, it's because we've got this, we didn't need to pass float at all, actually. Forget about using pass delta cast as a float. We didn't have to do that at all, actually. We just use magnet strength. Because this is being called every frame, we don't even have to worry about that. So let's change this back to, let's say, 0.5, meaning it should move half of its, as soon as it hits this radius, it should move half of the distance toward the magnet every frame. Well, we don't use 1 because it would be instantaneous, but I did see it slowing down. So they're slowing down a bit. You can see it slow down there. Maybe we need to boost this a bit. 0.7? Nope, still just slowing down. I think maybe part of it is that we have too many classes trying to move these things at the same time. Because let's look at the spawnable class. Spawnable class has a direction, it has a current speed, acceleration, max speed, etc., etc. Every frame, it manually moves its position. And now every frame we're trying to move its position as well. That's why I think the easiest way to move it is going to be by rotating its direction. Okay, okay. Just to prove that this can work. Just gonna look goofy. Let's see here. We are going to rotate the direction of every point that enters into our area 2B. Say collision direction equals collision dot direction dot rotated by a value of 90. So we're just going to rotate it 90 degrees and send it offline. I just want to see that happen. We don't even need to call update spawners. Anything that hits this circular wall is going to get rotated. Boing! There it goes. That's in radians, that's right. So actually, what we want to do is say F dot rad degree converting radians to degrees. Wait, no. That's wrong, right? Because rotated. Yeah, we want to convert degrees to radians. My bad. Degree to rad. So rad. We're getting rad. Okay, now we should see it make a sharp 90-degree turn. That might be what we need. Bing. Something happened down here. They're doing like a little loopity-loop. Because we were jittering? Is that why? Now, here's a question. When our coins are doing this little bob, that changing direction, that's influencing. Let's see here. Spawnables, when they bob. Position change. so we're checking the collider. Collision shape 2D is what's moving. Is that public? Set as private. Change it to public. But we don't want to actually move the collider independent of the node itself, so I think ultimately what we're going to have to do is we're going to have to change the way that we move spawnables. We're going to have to change it from a direction and updating its position to instead doing something like doing a move and slide and relying on a node's velocity. I think we might have to do that, but actually, do all nodes have velocity? Let's find out. So let's okay, this dot velocity, no, does not have velocity because it is not a 2D body. It's an area 2D. Okay. In that case, we can simulate a velocity. Now when we move our item, instead of changing the position, this direction times speed times delta. Why do we have this copied here? This is, oh, by current speed times float delta. Some of our spawn will ramp up in speed. Which of our spawnables ramp up? Think about it. One of our exploding objects, like the debris fields or something? Should we have that there? Oh well, anyways, we won't worry about it. We're going to change this here. Keep it around, just in case I decide I want to change it back later. Say this dot velocity. Equal to this dot direction times etc. etc. Then, when the move method gets called, because we should only have one method that's ever moving the spawnables, say this dot position plus equals this dot velocity. Okay, that should work. Now, Or no, that's not right. We don't need to set this in the move. We shouldn't have this here at all. Right? That's what I'm thinking. Alright, this ramp business is making it more complicated than it needs to be. Why do we have a max speed? Should we not just have a speed? We have an acceleration, we have a current speed. Make sure we're not moving anything anywhere else. No wonder I had written make more clean and elegant. This is just sloppy right here. Alright, this current speed plus equals this dot acceleration times our float delta value, and we clamp it to be between current speed 0 and max speed. We should always just be using current speed. Let's see. Just say position equals plus equals this dot direction times this dot current speed. That is always going to be clamped between 0 and max speed. So if it ever hits max speed, back. What did I miss? Oh, just a whole lot of this and that. How are you doing, Nep? A whole lot of crashes too. We had some stream crashes, unfortunately. We are presently trying to draw our coin spawnables toward the center of our magnet radius area. We're just having a little bit of trouble with that. Probably because, you know, I'm overexhausted from being out and about, enjoying the nice spring weather. But also because, you know, we've been coding this thing on the fly. We find better ways to do stuff. It means we have to go back and refactor old stuff. Actually, you've always been here. That's true. We've been explaining everything to your little duck. What do you call it? Duckleganger, as it were. Which, you know, thanks for including him, as always. Yep, the Florida duck. Exactly. Alright, let's look at what this was present, or previously. Before we started trying to implement a velocity value. So we're gonna move. Private float at current speed. Show me all the usages of current speed. Move. Right there, eh? Okay, and that's video code. Alright. So we only ever use current speed here. What I don't love, actually. Alright, so what we know is that spawnable.direction is probably our best bet for modifying this presently, without changing a bunch of stuff. I really would love to change the way we have spawnables to not manually edit the position that they're in, but instead to have them just constantly moving every frame based on a velocity value. That is the better way to do it. And then we can make adjustments to that velocity from pretty much anywhere. So see, when our spawners spawn an item, it sets the direction of that spawnable, and that doesn't get modified at any other point within the spawnable class, I believe. We don't ever say, hey, this dot direction should equal something else. It always just moves in that straight line. So we should be able to, like, for example, instead of rotating stuff, let's just say collision.direction equals vector 2.up. So anything that hits this is going to go straight up, ideally, just for testing purposes. There they go. Bing! Heading straight up. Okay. And alter it. Why are they kind of drifting away is what I want. Is that because of the bob effect? Because all the coins are under a bob effect? Collider position also moves up. I think so. Alright, well, let's just try this then. I'm going to say collision.direction equal to should be it's this dot global position minus collision dot position might just work. Might just work. Me didn't do that because, again, I think it's popping out of existence. Let's find out where it's going. We're going to hit it, then we're going to say print debug log here. Position. Tell me where all these coins are going. Negative 349, so it's going way off screen here. Why is that? only changing the direction of it. Start global position minus. I change this to this dot position. Yeah, it's still getting sent flying out there. Remember, direction is just the angle, or the vector 2 angle at which our guy is. Oh, wait a minute though. We normalized it. Know what I mean, Nick? What if we normalized it to a value of 1? Because when I think about it, the length of our vector matters as well. Right now, when the spawners spawn one of these, like, look at this. Direction, it's a -1 value. It's vector 2 dot left, put it in. If we change that to a normalized value, I think the problem is we're hitting this, we're calculating this is exactly what it is. We're calculating the distance between, and then the next frame, we're shooting this thing off screen, and that's why it's going so far. Alright, let's try this. See what happens. Okay, they are getting repelled. But they are getting repelled at a nice little rate. This is good. You might not think this is good, but this is good. Because what does this tell us? It tells us that we probably got our math wrong here. Let's try collision dot position minus this dot position. Let's give that a go. That's the opposite of what we want. Yeah, exactly. No, we just gotta invert the polarity, you know? Yeah, I don't think it's doing anything now. Not drawing in anything. What did we change? Oh, were we using global position? Is that why? No, we weren't. We weren't. Alright, well, let's just give it a negative value then. We know we can draw stuff away. We draw stuff in. Alright, guy up here, you're important. See, that's as low as it usually gets, and now it's getting a little lower. Oh shoot, you know what it is? We're only doing it once. We're only doing it once now. We're only hitting this on area enter, because we were doing this for testing purposes. Let's move this to our update influence spawnables method, we should be calling. Spawnable.direction. Position minus spawnable.position. Normalized, of course. Now, every frame we have to do this. Okay. Now it should go zoop, get drawn toward. They don't go. Not seeing it get drawn toward at the rate that I would like to see. I'm thinking, let's see, this reaches its peak here, feel like it gets a little closer, but is it because of the bob? Let's see. Spawnables changes the position of the collider, but the collider is still parented to the spawnable itself, so that shouldn't be a problem. I sure hope no one changes one of your semicolons to a Greek question mark. Is that because they're the same same symbol? I wonder if it would throw an exception or not. It would cause an error. I'm getting a lot of errors here. Able to cast K2D to spawnable. Okay. It's probably for like the debris stuff. It is? Oh, I figured. Magnet. Stuck global position. Opposite. I'm pretty sure this dot position is... Oh, I think we're capturing. We're moving it away slightly. No, we're capturing there. Moving those ones away. What was that about? Look, see how it's moving up? This one moves toward. Alright, something funky's going on here. Whack, whack. Alright, when we ready up, what do I want to do? I want to print this dot position. And print this dot global position. Compare the two and see what it is we're actually working with here. I just haven't got the mind to do math right. Alright, so our position 41, negative 24. Okay, that is the position of this here compared to its parent shape. Right, so it's over by 41, up by negative 24. Okay. The global position, where it actually... You know, we would have been able to see this just in its transform value as well. Yeah, so that's its offset. The global position is what we want to work with. Okay. Glad that it has a built-in function. Suppose we'd have to search up the scene tree. Okay, so we know that... Let's actually figure this out here. Our spawnable direction is going to be equal to spawnable dot global position it's technically going to be considered a higher value. Like if it's on the same plane, it'll be considered a higher value than our magnet position. So we want to say this dot global position minus the spawnable's global position normalized. That's going to be our direction. Well, it's within the sphere. Let's see if that works. Let's see if that works, huh? Zoop, zoop, zoop. Oh yeah, buddy. Zoop, zoop. We got a magnet. We got a magnet, Nep. How do they work? How do those magnets work? Actually, we got one caught. We got one caught. Oh shoot! You know what that is? That's not one of the coins. That's one of our exploding dead coins. They're getting caught there too. Okay. And they're not disappearing. Alright, we can draw in coins. We just have to change... Let's see. Spacevan right now has its dead coin value as our coin prefab. Okay. We could probably do a quick hack here. Let's see. When we eject coins... spawnable coin equals the dead coin, okay. Okay, so we have active values. So here's what we're gonna say. On area entered, if the ID is equal to coin and the collision area 2D is active. Hold on. Active. If it is active, we'll draw it toward us. Magnets just work, yeah. But how do they work? It's the age-old question. Passed down by philosophers. Shaggy 2 Dope and Violent J. Alright, now this should work. Now we should be able to attract coins and explode coins. Check this out. Zoop, 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 zoop. Coming in. Then when we hit a rock, boing, our dead ones still go flying. Okay. This is great. Because now this also means that we can if we want. Set a, and look, they're actually, like, going up into the magnet. Not just toward the Spacevan, but up into the... Great. Zoop, 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 zoop. Let's see what it looks like from down here. Zoop, zoop. So I'm thinking we'll probably want to lower the radius at which the magnet works. So that it's basically like skimming between two lanes. So that its real purpose is going to be for like when you're just passing by a lane and sometimes collect coins from both of them. Because otherwise you're just like stealing them off the lane above you. Or I think if you're on the top lane, yeah, stealing from the lane below you. Not quite. So it's always got to be the top one. Man, that was a big one. Big one. Okay, well, we got something done tonight. That's good. I am a little bit exhausted, you. Unfortunately. So I think we will probably call it there. We got a nice new function going. That's great. We got a magnet that's going to work. I think what we're going to have to do, and I'll probably do this in the off time between streams, I would like for it to like flicker on and off as it sort of appears, because we're gonna have it be a redeem, like the missile. It would like boop, 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 into existence. It would also be nice if we could visualize the area with like a we could use a shader maybe to like warp the space behind it. Space texture. That would be cool. I'll see if we can get that working. Or I might save that for stream, because that might be interesting to watch be done on stream. But I will try to work out the redeem, so we have that set up for next time. Otherwise, we're just like creating a redeem and copying out its ID and pasting that into code. That's not very exciting. But we'll get that going so it's good to go next time. maybe implement a weight for the magnets. And if I really get around to it, I'll probably change up the way that we do spawnable, so that they do have a proper velocity that we can more easily edit from outside the class. Alright. Well, you guys, that's going to be it. Let's head on back to the main screen here, and let's get ready to close out the show. Sag, no, we got a lot done tonight, Neb. We got a lot done tonight. Well, we got some done tonight. We spent a lot of time explaining stuff, spent a lot of time dealing with the stream going down, and we spent a lot of time fooling around in code, cracking our heads against the wall. You were just about to explain electromagnet. Well, give us the quick notes. Give us the quick version as we log out here. Let me take my hands off. There we go. As always, I'd like to set up a little raid. Let's see if anybody we know is streaming tonight that we can go and say hi to. Just a short little stream from us. But you know, there's always other fine folks that we encourage our friends to check out. Let's see. As Nep explains electromagnet to the best of his ability in under a minute. Maybe we'll go say hi to the Nova Swarm. They like doing indie games as well. They've released a couple of theirs. We'll do a little shout out and send everybody over. And Nep says here, hold on, what is this? Electrons spin and move around cloud, make current. Current also is magnet 1, same stuff. Alright, pretty straightforward. I fully grasp it now. Okay, that should be it. Our little shout out there. We're gonna go say hi to Nova Swarm. Make sure you say nice things. Be on your best behaviors, everybody. Thanks for joining us tonight. I hope you learned a little something. If you didn't, I hope you at least enjoyed listening to Spaceman. Learn a little something. We'll continue to improve on this and use what we learned to hopefully put it to good use when it comes time for that game jam at the end of the month. That's what we're looking forward to. We're probably put together like a team or something like that. So Buffy, if you're looking for somebody to work with, you just let us know, because I'm down to make something. I'm down to participate. All right, you guys. As for our show tonight, that is it. So, I want to thank each and every one of you for tuning in tonight, wherever and whenever you are. You can join us again next week, same time, same place, 8 p.m. Eastern, right here at Harbor Station. We'll catch you on the other side, Space Cadets. Until then, of course, no matter what life throws your way, good luck and Godspeed. This is Vector Spaceman, signing off. Stick around for that raid, because we're about to send you off for some more great content for your evening with some more great folks. Until next time, you guys, take care. We'll see you again real soon. Bye-bye.